Welcome to section 10.3 for Math 2, which is on division properties of exponents. So let's begin with thinking about what that means. So we're dividing two powers with the same base. So like x to the a power and x to the b power. All right, so let's think about what that means. Let's make up some examples. Let's say we have 2 to the 5th divided by 2 to the 3rd. Well, if we expand it, that's 2 times 2 times 2 times 2 times 2, 5 times, and that's being divided by 2 times 2 times 2 times 2. So 3 of them. Then we know that every time we have a 2 divided by a 2, that's going to cancel. So we can go and cancel, cancel, cancel. So what do we have left? We have two 2's on the top. And so the rule basically is you're going to take 5 and 3 and get 2 by subtraction. Okay, so our general rule is you're going to have the same base, but it's going to be the top minus the bottom, and that order is really important. Okay, it's the top minus the bottom. Okay, you can also alternatively do what I just did and expand it and cancel, and that works too. All right, so rewrite the expression using the base only once. So 4 to the 8th divided by 4 to the 5th would be 4 to the 8 minus 5, or 4 to the 3rd. Okay, here we've got a couple things going on. We've got regular old numbers. Okay, when you've got regular old numbers, you have to treat them as if they're regular old numbers, so they don't subtract. Ask yourself, what would you do if I just said, what's 8 divided by 12? Simplify, and you didn't have the x stuff there. You would go, oh, let's reduce. 4 goes into this twice, and 4 goes into 12 3 times. So this is 2 and 3. So they're just regular numbers, so just treat them as if they were regular numbers. Okay? All right, so then now, so you're going to have a 2 on the top, you're going to have a 3 on the bottom. Let's talk about the x's. These we're going to, actually let me erase this giant fraction bar. These we're going to subtract our exponents, so that's going to be x to the 3/2 minus 3/4. Yes, these are fractions. And yes, to subtract fractions, you need common denominators. So you might want to do this part on the side. So the common denominator between 2 and 4 would be 4. So let's multiply this fraction by 2 over 2. That's going to give me 6 over 4 minus 3 over 4. Now 6 minus 3 is 3 over 4. So that's what our new exponent is going to be. So finally, full answer, 2x to the 3/4 over 3. Number 3. We have x to the 3rd and y to the -2. It's x times y to the -2, all being taken to the 3rd power. So we're going to have to use a rule that we learned in a previous lesson, where we are going to have to cube each of these things. And you really need to do that before you think about the division. Think order of operations, parentheses first. So that would be x cubed, and then y to the -2 cubed. And then there's nothing to do at the bottom right now, so just copy it. So we have the rule that we learned before, where we have a power to a power, so we're going to multiply. So this part right here is y to the -6. I don't want to write the whole thing all over again. Okay, so now we are in the rule where we're dividing. So we have to make sure that we're paying attention to each base at a time. So the x's are the same base, and then we'll do the y's. Okay, so with the x's, we have x cubed over x to the 4th. If we're using the subtraction rule, we're going to do it that way. which is going to give us x to the negative 1. For the y's, we have y to the negative 6 and y to the negative 5th, so that's going to be y to the negative 6th minus negative 5th, which is going to turn into addition. And that's going to be y to the negative 1 as well. So if we're not allowed to have negative exponents, remember that means they need to go to the denominator. So this is going to be x to the first and a y to the first in the denominator. The numerator will be a 1. Again, I'm making my fraction bars super huge. Okay, so it should be 1 over xy. Now, we don't need to write exponents of 1. We can just write 1 over xy. So this is a correct answer. All right, I want to show you an alternate way to do this. Instead of using the subtraction, over here, let's just do this real quick. An alternate way to do this is to first move the negative exponents. So, for example, y to the negative 6 would go to the denominator and become a positive 6. And y to the negative 5th would go to the numerator and become a positive 5. So let's just do that. I'm not doing anything else. The x's are positive, so we're going to stay the way they are. Then you can imagine canceling, or we can expand it. So this is really x, and then 5 y's. And the bottom is 4 x's and 6 y's. This is a little bit of a tedious method, but it might help you understand it. Then we cancel. So x's cancel. 3 of them cancels, but there's still 1 left over. And then we have 5 y's. I'm just going to cancel them all at once. And that's going to cancel 5 y's down here, so there's still that 1 y. So that's the same answer. You're going to have 1 x and 1 y in the denominator. Okay, let's talk about raising quotient of a power. This is very similar to raising a product to a power, another rule that we had. This is if you have a quotient. Quotient means division. So let's say we have a over b being taken to the nth power. Then you're going to have a to the nth power divided by b to the nth power. So for our first example, we would have 4 cubed over 5 cubed. Since this says simplify, we're going to go ahead and figure out what 4 cubed is. That's 4 times 4 times 4. We can use our calculator and we'll get 64. And then 5 cubed, 5 times 5 times 5 is 125. Okay, same idea here, a little bit more complicated. We're going to take x to the negative 2, and then we're going to take y cubed to the negative 2 power. So we have a little bit more going on here. We have negative exponents, and we also have power to a power rule happening. So those are going to multiply and give us y to the negative 6. So we have negative exponents, and negative exponents should be rewritten to be positive. So we have x to the negative 2 on the top. He's going to go to the denominator and become a positive 2. The y to the negative 6 in the denominator is going to go to the numerator and become a positive y to the 6. And since they are different bases, x and y, we cannot subtract our exponents here. So this is it. This is the answer. All right, one more. We have fractions this time. The process is pretty much the same. So in our numerator, we have b to the 2/5, and we're going to take that to the 1/2 power. Our denominator was c to the negative 4th. We're going to take that to the 1/2 power. So we have 2 power rules. So these are going to be products. We have to multiply. Okay, so maybe do this on the side. 2/5 times 1/2. The 2's would cancel, and we would get b to the 1/5 power. For -4 times 1/2, put the -4 over 1. The 2 is going to go into the 4 twice, and that's going to give us a -2. So this is c to the -2. We have a negative exponent left, so we need to move this to the numerator. Let me clear some room here. And so our final answer is going to be b to the 1/5 power times c to the second. Now, since I moved everything from the numerator to the denominator, there's nothing there except for a 1, which we do not have to write. Just keep that in mind. So this is our answer. And finally, let's look at dividing powers in scientific notation. So we are going to have two numbers in scientific notation dividing. So we're going to basically take these numbers that are not exponents and we're going to divide them. Okay, so just figure out what this is when you divide them. And then it's going to be times 10 to the, and then we are going to take our exponents and subtract them. Top minus bottom. So let's give this a try. First we have 8.4 times 10 to the -3rd, dividing by 2 times 10 to the -8. So A and B for my problem are 8.4 and 2, and then our exponents are -3 and -8. So let's get a calculator and let's divide 8.4 divided by 2 gives us 4.2. Times 10 to the, and then we're going to have -3 minus -8. Be careful with your negatives. We are taking this whole thing and subtracting this whole thing. So that would give us -3 plus 8, which is 5. And then there are decimals right here. Okay, there's a typo, if you may have already noticed, in example 2. This is supposed to say Earth, not Saturn. Okay, so the sun's mass is 1.998 times 10 to the 30 kilograms. So just to give you an idea of what kind of number that is, 1.998 times 10 to the 30th. Let's see if we can write that out. So that would move our decimal 30 places to the right. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22. I'm already tired. Okay. Let's just say the sun is very big. Okay. Very big. So all of these would be zeros. It's like, and I'm not going to write them all. Okay. Anyways, now that we understand how big the sun is, let's see how many times as great as the mass of the Earth is the mass of the sun. Okay, so the Earth is really big too. It would be 5.972 times 10 to the 24th. So you would move 24 times instead of 30. Still pretty big. So they're asking basically to divide. How many times as big is the mass of the Earth is the mass of the sun. So let's put the sun on top. The mass of the sun. And we want to know basically how many Earths will make up the mass of the sun. So 1.998 times 10 to the 30th, and then 5.972 times 10 to the 24th. Okay, so divide these numbers with a calculator, and then we're going to subtract these guys. Okay, so 1.998 divided by 5.972, and we get, let's just round this to 0.335. So 0.335. All right, times 10 to the, now we're going to do 30 minus 24, which is 6. Now this is not in correct scientific notation. We are going to have to move our decimal to the right once, so that it's 3.35 times 10 to the. Okay, so then when we do that, we have to consider where what our new exponent is going to be. So if you're unsure, let's get rid of all this. We can expand out the original answer. So 0.335 times 10 to the 6 expanded, we would move the decimal to the right 6 times. So that would be 335,000. So now we're going to put it back to where it should be. 1, 2, 3, 4, 5. So this is actually going to go down 1, and that's because we moved in the other direction than we're usually doing it. Okay, that would be it.